All right. Hopefully you can hear me online. Um, like I said, we made it to Friday. I know it's been a long week. This session is supposed to be interactive, fun, engaging. What we really wanted to do was explore how well we're actually doing fair data across oceanographic data repositories. And one of the questions I get asked a lot when I'm at different meetings. So I should back up. I am Matthew Biddle. I'm with NOAA's Integrated Ocean Observing System Office. I am the lead of the data management and cyber infrastructure community. I'm a community manager. And I've spent various eras of my life at various different repositories, from NCEI to domain-specific repositories like BecoDemo and things like that. So through that time, I've had a lot of folks ask me questions, have requests to, can I actually go out and collect all of the data that was collected during these research cruises? And so these are some images from a research cruise that I went on back in 2010. It was on the U.S. Coast Guard cutter Healy in September of 2010. These are all of the different instrumentations and platforms that are deployed during these research cruises. And so a lot of the questions that we get is like, can I find the associated data that was collected with my Niskin bottle, my water samples where I did phytoplankton observations? Can I find the water temperature associated with that? Can I find, ADCP data related to the currents in that area too? All of these instruments are typically funded by different people, funded by different institutions. So you'll have NSF show up, you have NASA show up, you have NOAA show up. So how do we get to all of these data? How can we find all of these data? And can we actually digitally recreate a research cruise that went out and find all the associated data and try to reconnect those? So one of it is a discoverability question. The other part is an interoperability question. How can we actually bring these data together and put them on a plot? And so the session today will be lightning talks from a few repositories, a few data access platforms. They'll introduce you to their systems and how those systems work. And then we'll go into a little breakout session for 20 to 30 minutes, depending on where we get to, where I want you all to go out and I have a prompt with some metadata elements. I want you to find all the data you can associated with that and kind of see what you learn through the process, with the hopes that alongside Carolina and I are the lead of the marine data cluster. The hopes is that we'll get some ideas as to where to take that cluster in the future to help us make more discoverable and findable data. So with that, I think we can kick it off. So we have Carolina on CCHDO, and I'm not going to try to define all these acronyms because
Hi, I'm Carolina Barris. I'm one of the co-chairs of the Marine Data Cluster, and I also work at CCHDO, which is a data repository. This is our homepage, and I've pulled out some of the key points from our mission statement. So we serve high-quality global vessel-based CTD and hydrographic data. So the cruises we serve go coast to coast and full water column top to bottom, and it's very high-quality data that other programs use for validation and calibration. So we are the official data repository for the Ghost Ship program, and we also serve historic programs like WOS and CLIVAR and related programs. We standardize all our data into community formats. So our mantra is, if you can read one file, you can read them all. There's some asterisks there, but that's generally our mission. And we also manage public and non-public data, like I mentioned, for calibration for Argo and ocean sites. So looking at our homepage a little bit more, we also you can search our data on other platforms, like we have an ERDAP server for people who like to access data that way. And you can also access it via the ArgoViz platform, which co-locates with Argo data. And there's some news and updates on the panel on our homepage for seeing the latest updates we've made to data. Oops, wrong way. So if you want to find data on the website, you can start at the menu at the top, and there's some preloaded keywords and basins. You can click on those to get search results. There's also a map search and an advanced search, and that just takes you to other interfaces where you can draw a box on a map or use some more advanced keyword and date criteria, and there's instructions on that page on how to do that. So any of those search paths will bring you to the search results page. Something nice here is you can bulk download all of the results from your search into one big zip file, and you choose which type and format you want. So also, you don't have to bulk download. So you can click on an individual cruise, and you can also access an individual cruise page from the search in the top that's on every page. And on the cruise pages, there'll be the same data formats available and also some additional information and data that's associated with the cruise. And this will change on a cruise by cruise basis, just based on what's available. So like on the left there's some links to other data repositories and then additional data on the page. Also note that when we receive data, we make it available immediately in as received format, or however we receive it. So you don't have to wait until we standardize it to use the data. And then, so I'm not going to go too much into this for the sake of time because this is a lightning talk. But so you can get more information about using the data and the data formats in the information menu at the top. And that will take you to our learning pages. And you can always email us. We're very friendly and happy to answer questions. And the last thing I will mention is we do have a library snapshot with a DOI, which is useful for citing the data, and that's updated monthly. So that's all I have. Thank you so much.
Okay, cool. Hello, everyone. My name is Amanda Lovett. I am the lead programmer for the SAMOS initiative over at Florida State University's Center for Ocean Atmospheric Prediction Studies. So SAMOS stands for the Shipboard Automated Meteorological and Oceanographic System. The idea came about in a workshop in 2003 and has since spawned into this operational product for, running for over 20 years now. We deal with a lot of data and a lot of ships. We accept data down to the minute in a near real-time fashion. So at this point, we have nearly 3 billion 1-minute observations available. We operate using both a visual and an automated quality control system. So we like to think that we have some pretty high quality data available. And out of that data, over 95% of it has passed our quality control measures. We frequently, make publications and reports about this data. And we are always, happy to provide support wherever we can. So in terms of the kinds of data that we have and we work with, we have navigational data like position, heading, course over ground. We have meteorological data. That's going to be, more like your air temperature, your wind speed, wind direction, and oceanographic data. We measure salinity, conductivity, sea surface temperature, and more. And not only do we serve the data, but we also create products with it as well. Most recently, we have headed the Marine Flux project, which is a project in which we've calculated air sea fluxes from SAMOS data as well as a few other data sets. And this information is all available not only in ERDAP, but also we have a Marine Flux Explorer user interface, which allows you to plot cruise tracks on a map as well as plot the actual data value itself. You can actually compare air sea fluxes between like two ships, like on the same visualization, all on this web interface. It's very cool. I suggest you try it out. So in terms of the way that you can access SAMOS data, we have a few different means of doing so. You can access it directly on our website at samos.coaps.fsu.edu. There are options in our drop-down menu to access by date, access by cruise. You could even search by a ship's, variable attributes or vessel attributes if you're interested in metadata. We also make our data available through threads and FTP servers. And we also archive the data at NCEI each month. So it's available from multiple sources, and any user is allowed to obtain data from us of any quality. So if you're interested in the raw data or just the automated QC data, but not the visual one, or if you want fully research level high quality data, all of that is very readily available. And so to sort of wrap out the talk, I'm going to give a quick example here of what it's like to search for data for the this cruise from the T.G. Thompson. In this case, we are using the SAMOS webpage's access data by cruise feature. I will note that this is available for ships that we have in partnership with R2R, which you'll hear more about later. Primarily because we key on cruise ID. For our non-R2R ships, we would need a definitive source ID that we can use to track how these ships are moving. So if you search by cruise, you will be able to see, you can access, again, any quality of data that you wish, as well as check by the, you can see the little green that shows that this is high quality data. And if it's anything less than that, it will warn you visually. And yes, that is all the time I have. So
perfect. Hey, I'm John Relf with, as Matt said, NOAA's National Centers for Environmental Information. And actually, I'm going to talk about R2R data since you brought it up, which you'll hear more about later. But I work with the R2R project to archive their data. And also, I'm a member of the R2R FAIR working group. And so thinking about ways to make these data more fair. But what I'm really going to talk about is NOAA's one stop. And hopefully this will work. All right. So cruising for data at NOAA one stop. So I got a request to remove some data from a data set. And that made me think about this cruise on the Roger Revelle as a RR 2205. So I want to find all the data for that cruise. So I go to One Stop, I type in RR 2205, and I get a list of results. And look, there's some geophysical trackline data and some other stuff. What I'm really interested in is cruise data. And that's this one at the bottom, which I couldn't get a screen snap of. I'm sorry. But if you click on that last one at the bottom of the page, you get a landing page that says, oh, look, lots of cruise data from the academic fleet, which is not that useful because I just want one cruise. So I go to find the granules in that collection, as they say. So show me the files. And when you do that, you get a list of many, many, many cruises. But I can filter that using the filters on the left. So I type in my cruise ID again. And look at that. I find the cruise of interest. But I really want to see more about that so I can show some details. And the NCEI landing page has a lot of information about the different data that was archived for this cruise. So if I jump to that, I can see the types of data, CTD, XBT, etc. But more interestingly, I can get a link to the original cruise at R2R. And then I can find out all of the data that's associated with that cruise, whether it's been archived or not. And so that's how you get from One Stop to R2R to find the data that R2R knows about, which made me think, okay, that's nice, but maybe I should have had all of those links to the data sets, whether they've been archived or not, in the NCEI landing page. So now I'm going down this other path, but that's what I have to show. Thank you.
All right, so we're yes. Thank you for the preview, and thank you for organizing the session. I think it's a really important one. So rolling deck to repository is R2R, and R2R takes what we call the routine underway data from the academic research fleet. So it's the whole set of UNOLS vessels. We get that data distribution directly from the operators. We've been doing this since 2009. If you're not familiar, the underway data is largely the instrumentation that's permanently installed on the vessels and run by the ship techs. So we don't do sort of all the very heterogeneous science party stuff where they bring something on that goes to usually BecoDemo or another repository. We also don't do science party post-processed products. So this is the raw data. And for a subset of the data, we do our own light QA/QC and create standardized products. We have a variety of access points. So there's a human user interface web portal. We do have API services, but right now we do not have a direct API for data downloads. We need to figure out, we've got some big data sets and we need to figure out just the egress challenges around that, how to manage that. But scheduled in the coming year, we're going to work on that. We're going to work on an ERDAP for those data types that are appropriate. We do then, as mentioned, contribute a subset of the data types to NCEI. They can be found there. And from there, they wind their way into global products like the World Ocean Database and SUMD. You can see on our website, you can search, just on the usual variety of things. And we're working on enhancing discoverability through a few mechanisms, including this reciprocal linking. So we do have a cruise matching API. And one thing I forgot to mention is that R2R does create DOI dataset landing pages for cruises that we think are authoritative. We work with the UNOLs and the operators to make sure that that set of information is right. So we'd like to offer those DOIs. There's data from other vessels in the world, but for the UNOL's fleet, we'd like to offer those and our cruise ID matching service as a potential connection. So then we have a set of other API services. And we work to create links out to data from this cruise in this set of other repositories. We would love to increase that. We would love to do that in a more automated way. If they want to reciprocally link back, we're happy with that. So we are here and we're down for the conversation that is coming. Thank you very much.
Yeah. So I'm Courtney. I'm an oceanographer with NCEI, and I'm going to take it down from data manager, accessible like resources and research thing. Hypoxia Watch is really a resource for teachers or the media and, just casual viewers, the public, people who are not so involved in the research side of things. But researchers do also use our viewer. So it's kind of we're making a balance between making things easy for people to access without any prior knowledge, and then also making things accessible to researchers in a way that they're used to. So I'm not going to read everything on here, I promise. But this is for later if you want to read about why we are at NCEI. So Hypoxia Watch is a near real-time hypoxic viewer. And we are the only near real-time viewer for this phenomenon in the Gulf. We do have an annual cruise with NOAA that goes out every year and has been going out since the 80s. And we also include that data in this data viewer. But this is happening in real time so people can follow along. And usually our users are media or teachers or people, like undergrads and high schoolers and stuff like that, because there's a phenomenon happening out in the ocean. They're realizing it's happening. It's causing fish kills and they want to see what's going on. So a lot of times you'll see our maps in the news if there's a big event. If there's not a big event, people don't really care that much, honestly. So this is our annual cruise that is done by NOS and NGI, and I'm missing other people, and NCOS and NOAA. So we are mandated to do this kind of monitoring by the HABs and Hypoxia Research Control Act, which everyone calls HABARCA. So that's just background, why we exist, why we're at NCEI. Actually, the reason we're at NCEI is because we had the means and the ability at the time to create this product in near real time. So we have the data archives, we have relationships with the fisheries team out in Pascagoula. I'm located in New Orleans. And so, yeah, it just started and it's still going. And we have about 26 years because we started in 2000. So 26 years of data. And so now we're able to actually kind of get towards hopefully getting some normals or some longer data sets in there. Anyways, the stuff y'all care about. We recently just went through this. This is why it says beta. But after this year, this is going to be our map viewer. We recently went through a refresh and we moved into the ARC GIS experience builder platform. So I would love if y'all could I think I linked it on the slides, but I'll also send it out. But if y'all would like to give us some feedback on this, please, for user experience, I would really love that. But yeah, so we're kind of trying, like I said, balancing people who are not really familiar with accessing data through APIs and stuff like that, and researchers who are trying to access data. So we have lots of layers. I have a map viewer tutorial on our website. I don't have enough time to really go through it. But yeah, so we have a links and downloads, which is really what people are trying to get at. And there's we access the archives through it. We access our WAFs, and we can access the near real-time maps that we're making. Okay, sorry, I'm trying to rush, so I'm really not explaining this well. But this is our overall workflow as it is right now. We take FTP, the fisheries data, it gets FTP'd to our servers, and then we collect those every 2 to 3 days. We create our own contours, we do some QC on them, and then we basically send off the shape files into the geodatabase and the WAF, and then we make that available through the portal, the Hypoxia Watch map, and then we archive all the CNV files. So all the raw data gets archived from the ship. So that's dissolved oxygen, but it's also temperature and salinity and anything else that comes off the cruise data gets, you can access those through our archives, which is a link on this last page down here, but it's probably way too small for y'all to see. And yeah, and so we moved into this kind of experience builder because I want to start adding more and more data sets that like gliders for my use and trying to get more and more of that near real time data sets, because right now we're really only taking 1 or 2 cruises a year in, and I think it could be more useful to have more data, obviously. So that's it. There's probably a lot of things I didn't really go over that well, but yeah, that's kind of how our thing works. Sorry. Oh, perfect.
All right. Thank you, Courtney. I hope you're all getting an idea of how many repositories are out there and where data came in. And this is why I wanted to have this session, was to explore all the different opportunities. So Corey, go for it.
Hi, my name is Corey Levinson. I am a software developer and also a graduate student in the soils group at UC Davis. But most of my work kind of spans different types of data standards for different types of climate interventions. And I'm here talking about some work that I do in the ocean space, specifically with an organization called the Carbon to Sea Initiative. They're a funder of what's called ocean alkalinity enhancement, which is one of the many different ocean carbon removal pathways that researchers are currently evaluating right now. So a little background on OAE. This is a map from last year from this organization, Ocean Visions, sort of showing the different types of field trials that are already being explored from different groups. These span academic research, NGOs, and also some commercial pilots. Standardization is important for this, for individual projects to be able to analyze results, but also for any kind of intercomparison across projects in this space. So Carbon to Sea Initiative, who's this nonprofit that's been funding a lot of this different research. One of the projects that they launched last year is called the OAE Data Management Protocol. Submarine Scientific is the organization that I'm working with. They're a consultancy that initially facilitated a bunch of workshops and feedback processes with the OAE research community, trying to think about what are the different types of metadata that we want to be collecting from these field trials. we spent a lot of time working with NOAA and their OCADS group, trying to make sure that the mapping of the stuff that we were collecting for the broader OAE community was in line with the stuff that NOAA had been doing for a while already for ocean carbon acidification. And I joined the project around September of last year, formally kicking off the technical tooling and translating what had been done in those workshops into essentially a bunch of metadata tooling, JSON schemas, and web applications to help that community manage and create metadata. So what we have for our sort of data schema is this 3-level hierarchy of projects, which are these long durational. You could think of that as like the funded research project. Then experiments, which could be shorter in duration. There may be multiple experiments associated with a given project. And then data sets, where you're getting down to the level of like specific types of data, groups of data that may be coming from an individual ship cruise, or there might be remote sensing, model output data sets, that kind of thing. So within our group of data sets, we also have 2 independent axes of variation a lot of the time. So there's variable types, which could be pH, TA, DIC, sediment variables, but then also, sort of independent of that, we're caring about the sampling mode, whether it was from bottle samples or continuous underway data. And the kind of cross product of these two results in this pretty complex like variable classes. We have around 20 of them that each have unique and specific metadata for instrumentation, calibration, and QA metadata. So what we've created is a web application that is adhering to a JSON schema artifact that we've developed internally. This is all open source code, both the web UIs as well as the backend schemas that we're managing. And researchers are able to use these tools to manage their metadata and then export and basically have these standardized JSON files that they can then attach with their data sets wherever they're uploading their data, different kind of domain or generalist scientific data repositories. So here's a little back end of what that schema looks like. So on the left, you're seeing where we manage the schema. It's using this framework called LinkML, which is a framework for defining kind of a flexible data model in YAML. And then, as I was saying, you can compile that to JSON schema. But one of the nice things is it also allows you to hook in specific identifiers for RDF and URI terms. So if you want to be able to have these data sets exported to JSON LD or other RDF formats, that's also able to happen in a really streamlined way. So the blue circle that we're highlighting here is where we have an explicit reference, for instance, to standard identifiers for our variable class. And so that's, for instance, where we're hooking into CF standard names and things of that nature. So what we have in progress, and unfortunately this isn't live today, but this is something that I'm happy to sort of share with the group here, is also a discovery portal where we're planning to ingest all of these different metadata files into a kind of hosted, its own discovery portal, pointing out to the explicit data repositories in places where those data sets are being hosted. So, as I was talking about a little bit before, these JSON metadata files that we do have can translate into JSON LD in a pretty streamlined way. And so where we do have hooks for science on schema terms and identifiers like that, those can be very easily loaded into the sort of top HTML tags for these pages, making this discovery portal that we've been working on, hopefully like adhering to the other kinds of standards that different repositories are working on. So, this is a community project. This is open source software. So I want to make sure that like the ask here is that folks in this community who are working on different kinds of initiatives and standards, like engage with us. We're trying to engage with you all. These are GitHub links for both the schema and for our metadata builder. And the discovery portal, I think later this year, we'll be hopefully announcing and launching. Yep. Thanks.
Hello, everyone. I'm Brian Meyer. I am with the National Centers for Environmental Information, hopefully something you're all very familiar with by now. I'm focused, I am the Trackline Geophysics team lead. Trackline Geophysics is a blanket or umbrella term for a large number of different data sets that includes single beam bathymetry, marine gravity, and terrestrial gravity, both marine and airborne magnetic data, marine side scan sonar, and sub-bottom sonar as well. So I'm just going to be focusing primarily on our data discovery portal, which is a map viewer our data ranges from 1939 to 2026. So we host pretty much every flavor of data that you can, digitized TIFF images all the way to, digital data files. And so our map viewer is pretty user friendly, I think. It's pretty hierarchical, where in the top left you can see all the different survey types that I just listed. You can filter based off platform name, institution, collection agency, survey IDs, as well as when the data was added to the database. So if you come to our data set regularly, you can just try, and you host your own copies of whatever you need. You can come and see what's been added since the last time you were here. So here's an example of filtering just on sub-bottom profile data. So you could, these filters are OR filters. So if you want sub-bottom data and magnetic data, it will show you whether it has one or the other. So that's something to be careful of as you are navigating this platform. Also has bounding box. So in the upper right corner, there's a couple different options for your area of interest. You can click and drag or enter your coordinates manually. And so here's just an example of getting some data off the East Coast that's been added just since January 1st of this year. There's a lot of data. There's several thousand of these trackline data sets on this map viewer. So one of the things that we developed was this sort of pop-up that when you click on the trackline, it will highlight that area, that the coverage map, and it will give you some high-level metadata available for that cruise so that you could see if it's appropriate to sort of what you want. And that includes a link to a direct URL link to the data landing page. So this is an example of a JOIDIS resolution cruise. And you can see there is these what we call skittles under the types that show you the types of data that were collected during that cruise. In this case, it is bathymetry, magnetics, sub-bottom seismics of two different flavors. And in the upper right, you can see sort of what we call ancillary data. These are data that don't fit into the M77T data format. So in 1977, a group of marine geophysicists got together and designed the M77T format, which is a way to combine bathymetry, magnetics, and gravity data into a single file format. It is an ASCII format. It has since been made into M7. That was a fixed length field where it was filled with nines where the data wasn't present. So that was designed from transition to punch cards, and so now it's in an ASCII field, text tab delimited field, and so that's the M77T data, which is highly user friendly. So if you have any questions, please feel free to reach out to trackline.info@noaa.gov. We do know that our data access systems have had some issues for a while, so we are more than happy to build out manual orders for when you run into those issues. So thank you.
Thank you, Brian. Big round of applause to all the presenters. Thank you all for coming in and talking about your resources. I do want to open it up for questions. If anybody has initial questions from all the presentations, I'm sure everybody can have bunches of questions, but yeah, and I wanted to see, I saw some stuff in the chat. Yeah. So Sean Smith has a question for John about R2R, find several data sets, including those from R2R, but it does not find I can't read it, SAMOS data. So there's something to fix in the future, and that's it. Yeah. Let's see this one.
John Ralph, NCEI. And then Sean went on to answer his own question, which is that because Samos archives or processes and archives data by date, they don't include cruise metadata in the packages because it's just, data from this date to this date. Every day they do another day's worth of data. And so you can't find it because there's no cruise ID. So it's a fair discovery problem that we will think about, or that we need to think about.
Yep. Any other questions? And a question from Rich. Getting my workout in today.
Oh yeah. Yeah. Okay. Rich Signal, ex USGS. So like when John looked for his, R2, what was it? R2205. So I asked my agent, right, can you find this stuff at One Stop? And it did come back and found it, gave me a nice little table. But it looked like it maybe worked a little harder than it maybe had to, you know what I mean? And same thing with the track line. It'll find the track line data, but it chugs along for a while before it can do it. Are you guys working on, skills for agents to help, them make the journey quicker?
Yes, that's one of it.
Yes. The time frame in which we will make that happen is years. We are currently in the process of migrating all of our data to the cloud, and that includes populating a knowledge graph that will be much more machine readable and AI friendly. And then hopefully, because of the knowledge graph advanced relationship properties, we could start to connect the trackline geophysical data with the Samos data and the oceanographic data and all that kind of things. And then all the granules themselves will sit in an S3 bucket, which again should be queryable and more easily packaged together. But this is a long, drawn out process. So something we're in the works.
Okay. All right. Got two more questions.
Thanks. Raleigh Martin, National Science Foundation. Question for you, Brian. What's the connection between the trackline geophysics data viewer and the marine geological data system operated by Lamont? Because my understanding is both are serving kind of geophysical and geological data collected from oceanographic cruises.
Yes, it's one of those umbrella terms where the trackline geophysics holdings at NCEI contains most, if not all, of the Lamont holdings, but additional data as well from many other cruises like the IODP and just one-off data cruises from anyone who's received federal funding and has to comply with PAR and putting all their data into a official repository. They send their data to us, and there's the NOFOs and the OERs and all that stuff that isn't inherently hosted at other repositories.
Last question.
Jay Su from Nestis ACIO. I have a question for every speaker. Is your service on-prem or in cloud? If not in cloud, do you have a plan to do that? Maybe start from you.
All of what you saw in my presentation was on-prem currently, but it is being migrated to the cloud and should be there in months, theoretically.
Yes.
Mine's a lot smaller, so yeah, it is on the cloud. It's through the Geo platform. You can access all our data.
Yeah, so all of our data is on-prem. We have looked into, cloud services before, but at the moment, we're still thinking about, whether we think that's appropriate for our data or, if we can manage it as, at our institution giving, cost, et cetera.
CCHDO is in the cloud.
our data is all on-prem, and we are in a very long process to get to the cloud, but it will get there in a matter of months, and then with advanced data access that I was talking about in years.
I mean, the data doesn't really need to be like on the cloud, though, obviously, to support like agents, right? Like with so like like you could put an MCP server at one stop or anywhere, right? Or make the APIs more transparent to the agents or whatever, right? And I mean, unless it's giant data, it really doesn't need to be on the cloud, right? I mean, unless they tell you how to.
Yeah, I was going to say that's a policy question, not a.
So what is the cloud really? It's just somebody else's hardware. So we have some a little bit of our metadata database in AWS in the commercial cloud. The rest of our real data and resources are distributed across, like Forest State University as a research computing center and various open storage network backup. So yes, sort of cloud.
And I think Corey.
Yeah, I mean, for us as a discovery portal, right? So like the metadata is stuff that we will be hosting. Although initially the way we were thinking of architecting that was much more in like a crawling way. Like when we know that stuff is on certain repositories, we'll know to pull metadata from those and just kind of like index that more as like an on-fetch kind of architecture. Right now, I think our approach is to be persistently storing metadata within our own system, still pointing out to repositories, but how each repository is managing their own, data is kind of going to vary from one to the next, especially whether they're generalists or domain. The one case where we're having to do a little bit more active kind of guidance within our community is for large scale raster data sets. When you're dealing with model outputs, that's something that people aren't going to be able to necessarily throw onto Zenodo. So, we're in active communication with a few like different cloud providers for thinking about what's the best pathway to be, encouraging our like community of research groups to help them figure out where and how they should be storing like larger scale model output data.
And he just says for Samos, we at FSU are repository non-archive, thus we keep on-prem and leave the cloud to NCEI.
And then Eli. And then we do have to get to the workshop at some point.
As I see it, like one advantage of having data in quote unquote the cloud. So as I see it, but it doesn't, I guess it could be on-prem. It's just having the data out there in some format that we can have our machines read without like downloading the data. So like I work a lot now, like working on creating these, virtual data sets for NetCDFs, but we can also do the same. Like think about a lot of this is like tabular data. So I don't know what the format is. Let's say it's Parquet. But if you expose that, we can start creating things where we're bypassing your API and your UI, which I know you put a lot of work into that. And there are many, many users for whom that is going to be the way they get that. So, but it means that each UI is kind of different. And so it can be hard for us as a community to build tools because we have to build one for each different UI. Whereas if you expose the data and you do your own thing with your data, but you're also exposing it in a way that we can kind of ingest the structure of it and create new things on top of it and have like these standard UIs for like all data that can be put in tabular form, in Parquet, so not like CSV or something machine. So that's what I see as the advantage to quote unquote cloud. But again, I don't know, maybe there's a way that data can be on the server, but be exposed in a way that we don't have to download.
I agree. Um, I did see quite a few links to ERDAP in some of those presentations, which makes me excited because that gets to that programmatic access, to whether it's on the cloud, whether it's on-prem, doesn't really matter. You know how to interact with that server. There was a session, I went to the OpenScapes hackathon. I was working with Roland on trying to find some data. He was looking for glider data. I've said there's glider data on ERDAP. He's like, oh, just tell me the ID and I know how to work with that system, right? So it's, if you're using consistent APIs on the back end, whether it's threads, whether it's ERDAP, whether it's name it, a select few is useful because then we all know how to interact with it, how to use it. So I think just overemphasizing your point. I do want to get to the workshop activity. And I'm going to drop the chat. I don't know how many people are online. We got a couple? No. We have 2 people. So Sean and Frank, you're going to work together. And then the rest of us in the room, we're going to split up into small groups. How you can define your group size. When you do get into a group, assign a note taker and someone to talk after when we come back to a recap. I have a prompt on the next slide, and we just want you to write down your experiences. What we're trying to do is identify areas that we can explore for the marine data cluster on how to help discoverability and accessibility of marine data, specifically associated with cruise data, but it can be broader than that. And I'm hoping to do for about 20 minutes now, because I think we went a little over on the questions. But go out, explore, try to find data associated with a research cruise, and have fun with it as much as you can. The prompt that I have is when I gave that first slide of all the instruments and things that were deployed on that research cruise that I went on. This was the actual research cruise. It was Healy 1003. It was from September 2010 to the end of September. It was in the Arctic, Chukchi, Beaufort, and Bering Seas. So I give you a little bit of metadata. But what I'd like y'all to do is go around and find data associated with this cruise. Find whatever you can. If you can't find anything, that's a result too. And we can go back and figure out why you weren't able to find it. But if you can find data, can you bring it into a client and start plotting data sets together and actually do some interoperability with it? And while you're doing this, kind of think about what's making this easy. What are the challenges? What made it easier if you're using chat clients, if you're going to all the resources. The one thing I would say in the collaborative notes, so I'm expecting everybody to be on their laptop, which typically most people are during the meetings. In the collaborative notes, I have links to all the resources that the presenters were sharing. So you can go in there and you can click on all those links and go that way as well, or you can do a Google search. But take a look, see if you can find data associated with this research cruise and see what you can do with it. And then what we'll do is we'll come back and we'll talk about what you found, some lessons learned and potential ways forward that the marine data cluster can support this type of discoverability and interoperability. Any questions? Cool, clear as mud. I love it. So my ideal is somebody actually builds like a Jupyter notebook that ingests all of this data and starts making really cool plots. I don't think you could do that in 20 minutes, but prove me wrong. So I put it out there. Any other questions? Okay, go forth and do. Okay. All right. So Sean and Frank were online, and they had their own little breakout. So I'm going to have them report out first, and then we'll go around the room. We have about 10 minutes, so quick report outs and some lessons learned. I have up on the slide deck is just, what was your key takeaway, highlights, hurdles, and any recommendations you can give to help support, data discovery or access for marine data. So I'll let Sean and Frank go first.
Well, I think we just went and looked for let's say, like pathways. I think Sean first tried the NOAA one-stop collection to get a quick glance, but I think one data set showed up there, went somewhere to a coastal ocean data analysis product thing that didn't get any further there. For some reason, maybe it's not fully up and running. There's since I'm working with R2R, I went there first and see what we had. And there's a lot of links to multi-beam TTD navigation to SAMOS. There were also like cross-linking to Bico Demo and EarthCam. Bico Demo has also apparently a cruise track and some CTD bottle data we found. EarthCam link didn't work. I went to the EarthCam webpage and tried to search from there, but they don't seem to have any any samples from Healy 1003. So I don't know if there was any grabs or cores done. Then Sean went ahead and then actually did a broad Google search, just putting Healy 1003 in Google. And interesting enough, AI gave a good overview about the cruise. And then we followed those different links that showed up. There were a lot of hits to NoNCI, data.gov, which seems to have mostly the NOAA links from there. There was also, we found again the Bico Demo link. So there's different ways we tried to find some data. We didn't get any further than like looking what data is available in terms of looking there.
And when you said you looked at the AI response, was that just using the Google search and the default AI search
Yes.
AI client that comes up there? You weren't going into your own.
No, we did not. We just used that, and it had a summary with
makes sense.
With like dates, vessel chief scientist. So that was quite interesting that they pulled this information out.
Cool. So it is grabbing appropriate metadata from somewhere.
Yeah.
Okay, cool. Any other takeaways or recommendations you have?
Well, my key takeaway, if you can hear me, is not surprisingly that the data is everywhere. And, even if you can find it, which probably you can, being able to actually, use it in an interoperable and especially machine actionable way would be a real challenge.
Okay. Yeah, that's a great highlight. Okay, cool. I'm going to go around the room to the different groups that were here. Who wants to start? Right, left? You want to start? Okay. Rich is excited. He already started doing this during the meeting.
Okay, I'll go really fast. So each of us kind of took a different approach. I was just used me, myself, and I as a human, and then Matt was using kind of like a chat bot, and then Carolina was using like an agent. And I think Carolina got the furthest along, maybe.
I got some data and a list of different resources to look at, like what the agent thought was a comprehensive list of all the data it could find online.
Okay, yeah. So you did a slightly different.
And then we made.
Prompt.
I'm sorry. What?
Oh, I think you guys did slightly different prompts too.
Yeah. We started branching out.
Yeah. So I guess you did try to make a plot, but it didn't show up. That was interesting. The code that was generated.
It had really cool axes, but there's no data on the plot.
Yeah. There's also an error in the data read code.
Yeah.
And then, we just overall found that kind of each of those pathways had different challenges, which is interesting. So to think about kind of when we're optimizing this for different access pathways, there's going to be different things that we'll be focused on and what to prioritize. But one thing that Carolina mentioned was kind of making those context files for agents is an easy first step to help narrow the search. And those could be created and easily shared to people that are using those and like made by the groups that are hosting the data. So that's kind of cool. And then other small things were just navigating the landing pages was actually kind of challenging to actually find the download. And as the human, I was kind of struggling with like cruise ID versus other IDs across repositories. They weren't consistent. So that was confusing to me. But the AI seemed to get through that pretty well.
Yeah. And sorry to be confusing earlier. I did get a plot of, the single data file. And then we were looking for a second data file from that comprehensive list.
Well, we sort of got onto a tangent, so we didn't really complete the assignment. But we definitely spent some time. I was using mostly Gemini. I think really one takeaway for me is that I don't know what I should expect to see. So for particular crews, just we as the people who are storing the data don't have a great sense. Well, I shouldn't speak for everyone. Me, I don't have a great sense of if I look up a particular cruise, what should be coming back. And so I think just like establishing that as a baseline so that we can then move forward and say, okay, we're getting back 8 out of 10 results that we expect. What can be streamlined in the future so that we get to 10 out of 10 or something? That was my one thought to add. You guys have anything?
I didn't find anything. Claude did though. So
I watched Rich interact with Claude.
I mean, yeah, but it was just kind of funny. The first thing that came back was it said, "Oh, good, I caught a metadata error. One stop record for the multi-beam collection as a garbage bounding box. I pulled the correct one from NCEI." Anyway, but then it proceeded on, and it did like curl and download and all that jazz, and finally, we got some plot of some CTD stations and with profiles. Yeah.
So you just found CTD data. You didn't find anything.
We did the multi-beam bounding. We found everything, but then to make a plot, we just did the multi-beam bounding box because we didn't really want to deal with multi-beam data, and then did some CTDs. Yeah.
Didn't we just talk about that? So we also kind of went on some tangents, which was cool. We did find it on NCEI. I followed the exact tutorial that John and like the right box to click on at the bottom of the page and then filter by We did exactly what you showed us, and that worked great. We didn't download anything or make any cool plots, but we did talk a little bit about kind of, the amount of information that we're given versus like what people might be searching for. So it's like, I'm looking for temperature in the Beaufort Sea. Okay. Is that going to be a meaningful thing and path to get to that information? Are they going to go to something else, and so on and so forth? So we did talk a little bit about that. It's almost like you gave us too much information to search on, because I just typed it into Google and Google pointed me to like 3 different places that were actually pretty easy to get to the data from if you follow John's one-stop tutorial. So I think there's that. And then we kind of had some really awesome philosophical conversations about data access and publishing and all these sorts of things. So
cool. Yeah, I wasn't sure how much metadata to give. Initially, that slide just said Healy in 2010. And I was like, I'm going to get feedback that that's not enough information. And I found all this data and I couldn't get down to that specific one. So that's interesting that was the feedback.
So Matt, we're going to talk about this later, but I've thought about doing kind of a NOAA-wide data scavenger hunt where I ask people from across the agency to generate a list of 10 or 12 things that they think are either easy or hard to find, and then recruit a group of semi-technical experts that are not in our space to go out and do it, and then talk about it. So we can chat about that later.
Yeah, that'd be great. All right, we are at time, but I want to let the rest of the groups give it their 1 minute. So I hope you guys are all right with us going a little over. If you need to go, you can leave. Okay.
Here's the mic.
Yeah, go for it. The microphone's right there.
Yeah. All right. We went off on a different tangent. We took on a persona. We had an 8th grade teacher and 2 undergraduate interns, and we are creating an activity to help build for 8th grade class, building data literacy, graph interpretation, maybe evidence-based reasoning. And so in this activity, we decided the kids are going to come up with these hypotheses about where are marine mammals located? What would they be more associated with? And and then we had to look up what was in the cruise, found that just with Google. And so they could, more ice or not ice. And then we brainstorm, like, how would we do this activity? So then we found imagery, like pictures. So then we're like, oh, okay, that's fun. So our interns are like, they're from the computer science department, so they could build an app. So they decided they would make a map, and then the students go to all the pictures that were taken during the cruise and clicking on them in the map. And then the kids are gonna, like, rather than like digging into data, they're gonna click on all the pictures and kind of count up the in marine mammals they see, and that's how they're going to address it. Okay, so right, it's not perfect, but it's to teach data literacy and teach like reasoning, right? So what hurdles did our interns run into? So they found the pictures. Yay, that was good. And but they wanted to make this map, and so I think it was like trouble. You can say the trouble that the intern had.
Most photos from these kind of missions, when they get the metadata strip when they upload the data, so they have zero geolocation. It'll be nice to have like that kind of data along with the data in the repository, so you can that'll be easy for the AI. Even the agent can pair where this photo was taken based on where the ship was, and could be really simple if you had that metadata exposed. But it was kind of complicated. And the other thing is I guess this is an artifact of this kind of missions. Like when somebody's doing one instrument and another mission is doing another thing, it gets fragmented into different data repositories. So putting that back together into this is all the data that this mission took independently of where it ended up being hosted, that's difficult. So that knowledge graph of the, what is it called? The pedigree of the data, where it came from, the provenance. Yes, that is something that is not very well flushed out for missions.
Yeah, and that was part of the reason why I picked this cruise, because I knew there's different funding going on in different scenarios happening. So cool. Yep.
We tried to follow the directions. And Sarah was able to use Google to get a pretty good narrative description of the cruise and a number of good data sources. And that's great. It was a great starting point. Corey was able to use Claude to actually do a good search and provide a narrative description, then dig into some data and plot it and create a Jupyter notebook to do all that. So, one of the takeaways is if you have access and credits, then you can do quite a bit in a very short amount of time. So there were some challenges. Rich pointed out one of them, multi-beam data set is badly described. That's an issue. We discovered that you really had to do 2 or 3 level searches at some of the sites in order to get to the data themselves. That's a challenge. One thing that's really could help a lot is having a domain expert at the table. So the fact that there's a bunch of NCI folks here in this group made it really easy for Corey to. That's. Was there anything else that you thought we should say? Go ahead.
Yeah, I was just going to add. I think initially, without the Google thing, the reason we did that, part of the reason we did that Google search was because the first thing that we were doing, it was oh, what's going on? It was the narrative. None of the search tools that we were looking at were giving upfront, the very first thing, a narrative sort of description of the tool. So we found ourselves very quickly looking for, okay, we have a narrative question. We there's a desire for some kind of a narrative answer back, or at least structuring it so that rather than just oh, here's a list of bunch of data sets, but it's oh, we're asking about a cruise. Well, the answer is cruise started here, it ended here. These are these are how different data sets maybe do or don't relate to that.
Cool. Last group.
So kind of like the last group, we also had a lot of domain experts. So we had R2R and Samos. And then some from Hui to play with their data. But one of the things we found from a user interface perspective is we could do better by linking to these new web services. So Samos and their Explorer, we have no link from R2R to that. If someone wanted to explore in that area. And same with One Stop. I didn't know that existed, John. So it'd been kind of cool to be able to not just download the data, but then explore from these different cruise perspectives in the cloud, in the web service area. And then we also went in, we did plot some things. We used ChatGPT, but we had to download the data first to then create the plot. And then we used Xcode. Is that what we use?
I used Codex.
Oh, Codex. With his own agent, and he was able. Well, he didn't find R2R data right away, which was interesting.
That was really interesting. Codex did not find R2R as a repository initially. I had to tell that it existed.
Good thing R2R left.
we're still here. But the one thing I thought was interesting and made me think is when he did use that and got R2R, we plotted alkalinity on the track line. Is that correct? Yeah. And it pulled data from BecoDemo for the alkalinity from the bottle data. And then it pulled the track line, the lat long from R2R. But from a metadata perspective, you don't really know what instruments are collecting the data or any of that information. So I thought that might be something to think about in a metadata perspective, because now you have to go back. Okay, what instruments were on that ship that collected that data? And then from the Samos perspective, we realized that Samos really puts a lot of they really sort their crews, like their ships, by call sign. So like from R2R, we don't have any metadata on the call sign of the ship or the ICs code of the ship. Our main thing is cruise ID. So it's just made me really think about that metadata, that perspective.
Okay.
Yeah.
I just wanted to say something about the fragmentation issue. Like, because we have a lot of different repositories and repository managers, it's kind of unreasonable to expect everyone to develop their own MCP server to make it easy for agents to access your data. So, like, what about a community GitHub repo where we kind of collaboratively develop, an agents.md skills for our repositories, either to use together in one master one or like a separate little file, and that way it provides that domain knowledge to users who would use that skills repo.
And this was brought up at an IES meeting. I think, Rich, you recommended that at an IES meeting. Carolina came up. So this is something that is getting more traction. Now I've heard it 3 times. So 3 strikes and I got to do some work now. All right. Well, sorry we ran a little bit late. I want to say thank you, everybody, to all the presenters. Thank you all for coming up and talking about your stuff. And thank you for putting time into the breakout. Really appreciate it.